Well, hopefully it's repair time today. I have here a Raritan Dominion LX108 8-port IP KVM switch, which has served me well for many years now. It customarily sits in a rack at an offsite data center, and obviously allows me to gain access to a few servers there that don't have integrated KVMs like an iDRAC or a ILO. So here are the rear ports. As you can see, non-redundant PSU, VGA out, a few USB ports for keyboard, mouse, and I think it supports physical media as well. Obviously a LAN port, and then these are the 8 ports for the KVM. Oh my God, the remote heads. You know, it converts RJ45 to VGA and USB basically, or VGA and PS2 as the case may be. And on the front, not much to see, just a power LED. And I tried to remote into this the other day, and it just did not respond. And I thought, well, that's strange. So I went down to the data center and found that this thing was hot. And I don't mean like a little hot. I mean like almost too hot to touch. It was so hot. And the power LED was off. So I'm guessing that means a power supply problem and not a problem with the actual like microcontroller and whatever else is in here. And I don't know what's in here because I never opened this up. So let's do that and take a look. Looks like 3 screws on this side, 3 on that side, and that's probably about it. And there we go. Nice and clean internally, nice neat circuit board. Oddly, there's a fan, but it doesn't correspond to any intakes. Like there are ventilation holes in the sides of the case and a few vent holes on the back, but none on the front where the fan is pulling air. And I assume the airflow is this way, right? Oh yeah, there's an arrow on this side of the fan. Shows airflow would be this way, right across this chip. I'm not sure what that is, maybe an FPGA or something. And of course, here's the power supply module. Now, this sticker is sort of coming up off the... Oh, that capacitor looks slightly bulged. Maybe a little more than slightly. I don't know that this cap necessarily failed and that caused the problem. Of course, like this could have overheated, like this transistor or voltage regulator or whatever could have overheated, or this resistor, which is right next to the capacitor, causing the capacitor to therefore overheat and bulge. But yeah, it could just be a bad cap. And like I said, this is my first time opening this up. As you can see from the rear panel, it could theoretically have up to 16 ports. So I'm guessing whatever chips are missing here, and some other components down here would be populated for the 16-port version. And they would probably just have a 2-tiered RJ45 block, and you can see all the other connectors, all the other solder pads that would be for those extra connections, rather. Yeah, it's missing some other chips down here. Although, weirdly, it's only missing 8, whereas it has 16 of those, so I don't know. Anyway, we're not getting into the hows and whys this works, just so I'd point that out for fun. So I think first thing to do is power this on, verify that still nothing happens, and then I'm going to grab a thermal imaging camera and see what's hot after it's on for like a minute or two. Or maybe even less than a minute or two. Okay, there's some power. Let me switch it on. It's not making any noises, like any, yeah, it's not making any, like, bad switch mode power supply noises. And as you can see, the power LED is not illuminated. And just out of curiosity, let me get a multimeter and see if we have any power on the outputs of the PSU module at all. And are the specs written on it? It's weird. Yeah, I can't get a good angle to show this to you right now, but once I take this connector out, I will be able to. On the board, the red wires are labeled ground, and the black wires are labeled plus 5 volts. Seems backwards, but hey, it doesn't really matter, I guess. I'm not feeling any heat coming off this yet. It might have completely blown up. I should probably plug this into an isolation transformer before I go poking around in here, but, well, let me try not to shock myself. Actually, are we getting AC in? I don't see why we wouldn't be, but 120 volts. That's fine. And back to DC. No. Now it's making a little bit of a clicking. It almost sounds like it's coming from the fan, though. Yeah, there's basically nothing coming out of this. Oh, and this heatsink is wrapped around these capacitors, and yeah, they're all a little bulgy. Yeah, none of those capacitors look healthy. And I'm getting a little clicking noise. Yeah, the clicking noise sounds like it's coming from the fan. So I'm wondering, why is this reading 500 millivolts? Oh no, there we go. Okay, just because it was open. Yeah, it seems like the power supply might be trying to start up, and occasionally, it looks like there's some fluctuation there. No heat whatsoever. It's still making the clicking noise though, so it wasn't the fan. I was mistaken about that. So it's got to be this power supply trying to start up. Fortunately, the PSU is quite modular, so I can't really get to that connector easily. That's okay, disconnect it from that end. And now I can show you, yeah, ground and plus 5 volts. And this connector will be connected thusly, so the plus 5 volts will be on the black wires. Like I said, it doesn't matter, it's just kind of weird. Weird component choice. Yeah, take that off too. Actually, you know what? Kind of doing this troubleshooting in the wrong direction. I'm pretty sure the power supply is shot because of all those bulge caps. Like, those have to be replaced regardless. But let me power it up with no load and see if we have any voltage, because it could be a faulty component here pulling way too much current, dragging the PSU down. 245 millivolts. That seems to be just with the meter. Is this meter jacked up? Now it's reading 246 millivolts with the probe shorted. I don't trust that meter. Yeah, the only downside about this is it's got that, like, quite a reflective screen. And with the probes not touching anything, it's reading near enough. It makes no difference. 0. Yeah, this meter seems a little better, as one would kind of expect. Yeah, okay, absolutely nothing on the output. Now, of course, a faulty component on the board could have drawn so much current that it fried the power supply. So you know what? Let me get since we know it's supposed to be, well, it says plus 5 volts in ground, but then again, the red and black were the reverse of what I thought they should be. So I was going to say, let me run this off a bench power supply, but I don't want to reverse the polarity. Does this have reverse polarity protect? I don't see a diode right near the connector, at least not a, no. Ooh, that is toasty looking. Okay, so yeah, even though it's not hot right now, it was clearly very hot right around here because the board just looks sort of blackened there. And that is right under a lot of components, but notably, I think that's a resistor. It could be an inductor. Yeah, it could be any of those components in that area heating the bottom of this board. So I'm not really hopeful about this thing working. Oh, and here's some model information on the power supply stuck to this capacitor, which is great because then if you replace the capacitor, you lose the model information. So input 100 to 240, model PS35-5, Meanwell. Oh, it's a Meanwell power supply. It's a good quality power supply, most likely. And it just says plus 5 volts, 6 amps. And let me see if I can just verify the polarity of the output from the polarity of the... Oh, it's actually labeled on the bottom of the board, plus and minus. Let's see, does that... If it's labeled the same way on both boards, I'm going to assume that it's correct. Oh, I think it was just in the factory, or maybe someone was in here before me. If they put the cable in, connected to there, and then connected to there, the red wires would indeed be plus 5 volts. And yeah, there's markings on the bottom there. Sorry, it's a little out of focus, but it's V plus, V plus, V minus, V minus. And right now I have the cable oriented the correct way, so V minus is lining up with black. Yeah, so I think this cable was just put on backwards. Probably at the factory, just the way this was bent, like, yeah. So, okay, because of that, I think I am going to hook a bench power supply up to that and see what's going on. Because quite frankly, this is pretty old and outdated by now. I mean, hardware-wise, there's nothing wrong with it. It's just, it doesn't get updates, firmware updates from the manufacturer anymore. Like, it's using old encryption standards that modern browsers just get really pissy with and won't even interact with this thing. So it takes some configuration changes at the browser to actually use this. And the software on board, the web interface, is just outdated, kind of clunky. It works fine, though. So, like, I'd be fine repairing this. It's already set up the way I need it to be. And I already have my browser on my... Oh, Edge. I use Edge for, like... Because Edge still has Internet Explorer mode. So I use that for any outdated technology I tend to use. And I don't really use it for much else, so I don't care if I weaken the encryption standards on that. But if the board is shot, then there's no real point in repairing it, because it's probably going to be one of the customized Cs, or like I don't know if that's an FPGA or microprocessor, but possibly something with firmware on it. And it's going to be hard to replace, and this thing is probably worth like $20 on eBay at this point. I got it cheap, and that was 6-8 years ago. So I can only imagine it's even cheaper now. But if it's just the PSU, fine. All right, Keysight, what is this? E36313A. Wonderful naming convention. All right, so we'll set this to a max of, we'll just set it to a max of 6 amps and 5 volts. And I'm fairly certain that the positive and negative pins are just common together. Yeah, they are. These are pretty thick pins, too, for 6 amp maximum. And these are pretty thin wires. But I don't know that this thing is actually going to draw 6 amps right off the jump. So if these wires end up melting down, I guess we'll all have a good laugh. And power. Yep. We got an LED on the front. Let me just cut power for a second. I've got this Dell monitor that's somewhat period appropriate for the device standing by. Not that the period appropriateness matters. Not that the period appropriateness matters, but you know. So I'm going to power it back on. Again, the LED comes on. I think it's just red, and it's actually red and blue right now. It's sort of purple to my eye. It looks more red to the camera, and that's its usual startup state. It turns just solid blue when it's running fine. Now the fan's not on, so I'm guessing it's got a thermocouple or some kind of temperature sensor in there, so it turns itself on when needed. Oh, yeah. Sorry about the wire pattern. That's just the camera interacting with the monitor. That's not anything wrong with the monitor itself. See, if I defocus it a little, that'll go away. So if you're ever filming a video, by the way, of a monitor, and that's its startup noise. It does that all the time when it starts up. Anyway, if you get these kind of patterns when you're trying to record or take a picture of a monitor, if you just defocus it slightly in one direction or the other, I think that it being slightly out of focus is less annoying than that pattern. Obviously, if you need to show detail, then it's not that desirable. But here, I just want to show that it is actually booting up. Cool. So, power down. I'm going to count that as this working and it just being a power supply problem, which is awesome. So now I will try to fix the power supply. The fortunate thing is there's no weird power rails. There's no crazy voltages. It's just 5 volts, 6 amps. So I got a couple options. I could either get a new power supply that would fit in here, or alternatively, I could just use an external power supply, but 6 amps is kind of hefty for like a barrel plug. And I don't have any like high quality modular 5 volt power supplies like this handy. Although, if you can make it work in the case and mount it properly, a small computer power supply, like for one of those miniature desktop computers, might fit in here, and it'll be 5 volts, 12 volts, and probably 3.3 volts. But of course, you could just use the 5 volts off of it, assuming you'd have a way of powering it up, because it would probably have a soft power key. But anyway, okay, so here is a BK Precision isolation transformer. It's old AF. It's got direct output here and an isolated output here up to 350 volt amps. And it's got a selectable voltage matrix, which is pretty cool. Right now, with this switch is here, that corresponds to this column. And then with this switch down here, that corresponds to this row, so it would be at 120 volts. I like this. It's a neat little unit. Quite old. Does not have a date on it. I'm going to steal the purple cable. I like using multicolored cables on the bench, particularly for devices under test, because it makes it much more obvious if you just have like an IEC connector on the end of it. Like if this was just a black cable, I might have a few of these on the bench, and I might grab the wrong one that's not plugged into the isolated transformer, or isolation transformer, and yeah, could be a bad time. Well, first let's make sure we do in fact have AC in. It's actually dumb that I'm using this and resting my hand on the grounded chassis while I'm doing this, but even though it is isolated, can't hurt to be extra careful. Alright, so we got 121 volts. I'm inclined to desolder some capacitors and test them, because they're almost certainly all effed. And hopefully I have replacement parts in stock. Actually, this is a great time to break out my brand new Hako desoldering gun. So it's like a mid-range temperature. Yeah, well, it sounds like it's working. Solder's melting. Let's provide a little suction. Oh yeah. Oh yeah. That's nice. A little adhesive there holding it on, but the leads are definitely free because they're wiggling nicely. Oh yeah. Ooh. A little darkened on that side. Probably some leakage. Did it leak onto the... Oh, and definitely got hot. See, the board's a little charred there. Oh yeah, let me get an LCR meter and cheap but Keysight, so calibrated LCR meter with cheap probes that it came with. No matter, we're not like trying to get precision measurements here. We're just trying to see how bad this capacitor is. 4.9 picofarads. Picofarts more like it. And just for the record, this is supposed to be, so 400 volts, 68 micro, 105 degrees, yeah. Let me go check and see what I got in my... Actually, let me desolder more caps, because these are all bulged, so those are definitely bad. I mean, those aren't staying regardless. And those are smoothing... I mean, those are smoothing caps in the output, so those aren't going to be the cause of this thing not powering up. If anything, it would just give really sloppy voltage. So there's one more capacitor stuck in there. It's not bulged. It doesn't look bad. And maybe I can test it in situ. If I can see where its pins are. I think it's those two pins right there. I mean, I'm not a switch mode power supply guy, so kind of shooting in the dark here. 58 ohms. So, yep. Also rated 105 degrees, which is good. This feels really light, even for such a tiny capacitor. 25 volt, 100 micro. Yeah, this is just thinking it's a resistor at 1 kilohertz. So, yeah, and this is probably the key. Replacing this, I'm wagering, if nothing else has been fried in here, that might cause it to start up. So we need a 100 micro 25 volts or slightly higher, and a 68 micro 400 volt. Now, in theory, if I was always running this at 120 volts, I could go with something lower to handle the peak voltage. But I'll see if I can get a 400 volt capacitor. because at home I do run a lot of my servers and other equipment at 240 volts. I've actually got a video about that if you want to check it out. Alright, well, lucky me, I don't have any 100 microfarad capacitors, and I don't have anything 400 volt or even high voltage, because I mostly do electronics projects that are low voltage, so the highest I have are 50 volts. And what was this one rated again? So this one was rated 25 volts, so here I have two 50 volt 47 micro capacitors. This one was rated 100 micro, if you recall. So if I just connect these in parallel, that'll make a 100 micro capacitor, and we can at least test the power supply. And oh my god, it is really blackened down there. So I don't know, this might have suffered other damage too. Alright, well what I did is, this is just temporary, just to see if the power supply will start up, because these are also like poor quality capacitors. They're no-name brands. I wouldn't trust them to run this long term. But I was able to get two of each of their leads to stick through. Yeah, I'm just going to solder those in place. Omit this smoothing capacitor here, because I don't have a replacement for it anyway, or even anything close. And just see if we can get any startup on the power supply. And this is my trusted Stahl Tools soldering iron. It's nothing fancy. It normally does spend a lot of time on this bench, but I've been doing computer projects lately, so I put it away. And not long ago, I got a paste soldering station, a cheap one. Like, well, none of their soldering stations are cheap, but one of the cheaper ones. And I keep meaning to do a video about it, and I haven't. And so I'm still using this guy, which does heat up fairly quickly, which is good. I'm still going to use this for the inlet. Okay, that's currently powered off. Is it going to explode? No. Alright, nothing on the output. We do have 6 volts across the capacitor I just put in, though. Do we have anything on the other side of the transformer? Nada. Anything to this chip. I'm not sure what the pinout is, but... 107 volts DC across those two pins of this little chip. That doesn't seem right. Unless it's AC. I mean, I don't know what chip. I'll have to look up that chip. I don't even know what the pinout's supposed to be. I just doubt it's supposed to have that kind of voltage across it. I'm just wondering if now they replace that cap, if something does try to start up in here and it gets warm somewhere. Alright, I'm just going to order some replacement capacitors and then come back to this. I think is the best thing to do at this point.
Quelque temps après que l'éponge a émis des excréments.
Alright, I'm back roughly 2 days later, and I have some DigiKey parts. I did sort of the usual thing, and I over-purchased what I need, and I purchased very high-quality components. These are Rubicon capacitors, 68 microfarads, 400 volts. I measured them, of course, before I bought them. They should fit in that space. And they were fairly expensive, so I got 5 of them, figuring I'd use one for this and then have 4 spares. And I don't remember, I think they were 10,000 hours rated at 105 degrees C. Everything I got is rated for 105 degrees, and just like the old ones, but they also are long life capacitors, so they should be good quality. I mean, they are good quality. We have the 1000 microfarad or 1 millifarad 16 volt capacitors for the smoothing the low voltage output. We need 3 of those. I got, I think, 12 or 13, 2, 4, 6, 8, 10, 12. I got 12. So I'll have 9 spare. And last but not least, on the capacitor front, this seems too big, although I did measure it. Huh. Yeah, this is too wide. That's weird. I'm not sure if that was a mistake on my part or it appeared incorrectly in the search results because I searched by diameter. But this is the 100 microfarad 25 volt. I mean, it's supposed to fit in there, so this is going to be too fat to actually get down in there. But of course, I could just leave it proud. So yeah, that's probably what I'll do, is stick this one in there and just leave the leads long. It shouldn't be a problem with vertical clearance if it's sticking out a little bit, because it's a little out of focus, but just to show you the height we're working with, even if the leads were fully extended, it would still fit within the chassis, although just barely, but it'll be lower than that anyway. And I'm kind of shamefaced in that I didn't check the transistors to see if they're shorted, because that would cause quite an issue. I did get one more thing, or rather two more things, one spare if I end up using it. Both DigiKey and Mouser used to sell this exact model of power supply from Meanwell, but it's been discontinued. They no longer stock it, but what they do have is this Meanwell, sort of like an updated version. I think it has an amp of higher capacity, even though it's on a smaller footprint. It's the same width, and the screw holes are comparably spaced, but it's 1 inch shorter. And yeah, these are not measured in metric. These are measured in inches. I think this one was 2x4 and this one's 2x3. So obviously it'll fit in the chassis. I mean, its height is fine. It just won't attach to the mounting points, or not all 4 of them anyway, but we can solve that. And it does have the wrong connectors on it, unfortunately. But that's really not a big deal, because even though I actually don't have any connectors to crimp onto new cables, I really don't mind cutting off the old connectors and just soldering wires directly to either the board or to these terminals. The input pins have the same pitch, but it looks like, no, the pins themselves are also the same size. Yes, the input connector will be fine. The output connector, yeah, we'll deal with that if we need to. And I'm thinking about replacing it with this new power supply anyway, just because even if the transistors are fine on this one, even if the capacitor replacement brings this back to life, I still don't trust it, because it obviously experienced a hell of a lot of heating just based on the way the board is a little charred almost. It's almost beyond just browned. It's like actually almost blackened. It doesn't look like there was any arcing or anything. It's just dark, like it was heated for a long period of time, which it probably was, because like I said, the entire unit outside of this, the metal chassis, was hot to the touch. Not just warm, but hot. And to heat up that entire metal chassis when this is only loosely bonded to it, this must have been extremely hot. So even if the other components on here are okay, my worry is that they've experienced thermal fatigue and will die sooner rather than later. So I am leaning towards just popping in a completely new power supply module. Even though I know a lot of people are against modular level repair, it's like, ideally I would replace every single component on this board, active or passive. Like even that chip down there probably experienced a ridiculous amount of heating. So I don't trust the reliability of this, even if I could get it working with a few components replaced. $18 nanofards. ESR 4 kiloohms at 1 kilohertz. I mean, all these caps are definitely going to be bad. 111 ohms. This one's different. Oh, 2.7 microfarads. This is the healthiest of the 3 capacitors. And I think this is the one that was all the way on the end over here. And this one I physically damaged when I was taking it out. So, I mean, they're all bad anyway. Like, for sure bad. not just blaming capacitors for no reason bad. I guess let me throw in the components and then we'll see. Yeah, I mean, that one fits quite nicely. That one I definitely got the measurements right. And it's even actually the same height as the PSU, so I can just sit it like that and solder away. Oh, and I gotta put this little transistor back in. These shitty capacitors, this should theoretically, if this is gonna work, it's gonna work now. Like, because these capacitors are good. This capacitor is good. These capacitors have been removed, which are just for smoothing, so we should get a sloppy 5 volts off of this right now. Or it'll blow up. Power switch is off on the device, so plug that in, see if it blows up. Okay. I'm not getting any heat off of it, but there is an indicator LED near the output, and that is not lit. I've got my multimeter off camera right now, but let's just see. Yeah, no volts DC. Yeah, I'm just going to throw in the towel on this because A, repairing this kind of power supply is not my area of expertise, and B, I don't trust it anyway, even if I could get it working, which I can't through simple capacitor replacements. I watch Curious Mark and a bunch of other YouTube channels deal with retro hardware. And trust me, I know that like replacing capacitors is not a fix-all for every problem. You know, I've seen these guys like get equipment that's 50 years old and the capacitors in it are still within spec and still like brand new. The reason I replaced the capacitors on this, first off, is because all of these capacitors were clearly bad. They were all bulging. One of them was leaky on the bottom. The fault is elsewhere, but like I said, I ordered a whole bunch of these anyway because I want to have spares, so I can just take those brand new ones off of here. And actually, I only put one brand new one that's good on here. I could take that off, put it in my spare parts bin, and throw the rest of this out. Yeah, so let's just retrofit this into here and get on with our lives. And besides, this capacitor wasn't even the right size for this, so it's all a mess, is what I'm saying. Let's move on. What we need to do is fit this power supply in here. And oh, I guess I should test it first. I mean, it did just come brand new from DigiKey. I should think there's nothing metal under there. I should think it would be good, but can't hurt to just verify that it's at least got 5 volts in the output, right? Output, so not short the output. 5. Oh my god, I did short the output. Oh, I guess it has anti-short protection. That's good to know. 5.1117 volts. Which is, I don't know how accurate this meter is, but close enough. So, as I was saying earlier, here's the situation. We got these posts, which are... I can't even fit the thing in there. They are approximately 92.5 millimeters apart in that direction, and the space in this direction is, again, just roughly, I'm not looking for an accurate measurement here, 43.5 millimeters thusly, in case you were curious. So I can either mount this here to these 2 posts or here to those 2 posts and then figure something else out. Now this cable from the power supply connector won't reach if I mount it to those posts, so we're going to mount it to these 2, and then that will reach just fine. And then obviously this is the wrong pinout for the cable that came with the device, although, so actually it would be this connector in theory, but the problem is it's got that pot for fine-tuning the voltage, and if it weren't for that, we could definitely get that in there. In theory, I could bend that pot down, because there's plenty of room behind it. There's nothing conductive back there. No, it's still not quite going to fit. Not really. It pulls too much. Okay, as one option, I have these, they're cheap rising clamp terminals. I mean, you can tell by looking at them, they're cheap plastic. They wouldn't be good for multiple connections and reconnections, but their leads are thick enough that I think they would handle up to 6 amps. 5 amps or 6 amps, whatever it was. So I could replace one on the board here with that, one there, and then just use wire to connect between them, and they'd still be relatively modular. Just because those rising clamp terminals are not good quality in particular, what I'm going to do is just... Oh, these pins are bigger than my soldering gun's mouth. Yeah, it's not just that there's like a bunch of solder around it. Oh! Wait, there was. Oh, no, the gun didn't actually get around the pin. I'll show you in the other one because I'm going to do the exact same thing to it, even though it's silly. Yeah, you can see this pin is now proud of that one. It just pushed the pin up through the plastic housing as I heated it up. So I'm just going to do the same thing again. Yep. Alright, I mean, this is still usable anyway. You can just push that pin back down and it'll all be fine. I'm just holding the cord with my belly against the side of the table to keep the iron in place. Sort of like, well, you can't see my belly, the camera's out of shot, but yeah, sort of like this. My stomach or sternum is right here. Not sternum. My xiphoid process area is like right about here, and it's just pressing into the table, holding the cord so the soldering iron doesn't fall, doesn't go anywhere untoward, and also when you press down on the front of it, it doesn't hit the table. And this is how, if I'm tinning a lot of wires, this is what I'll generally do. I don't know if that's a pro tip or a dumb tip or what, but yeah. If I'm doing a lot of these in a row, it's just easy. Whenever I'm soldering wires coming off of a power supply or something like this, I like to lay them out in the way, approximately the direction they'll be going when they come off. So you can see they're kind of soldered at an angle, but I feel like that helps keep the strain off those solder joints and off the ends of the cable, because now they're already sort of aiming where they want to go ultimately when they're installed. Again, I don't know if that's like a pro tip or a dumb tip, but I just feel like I like to make wires comfortable, you know, even though they are going to be bent over like this, you know, but still, they're not going to be shooting straight up, is my point. So why not start them on their journey from the solder pads correctly? What I could very well do, of course, is unmount this main circuit board, desolder this whole connector, solder these on the same way. The reason I'm not going to do that, even though that's probably the correct way to do it, is because ultimately, if I have to replace this again or do some other kind of repair in here, I don't want to have to take out the main board, which isn't too much of a hassle. It's just 8 screws, and then desolder this from the back. I am going to go a little crazy and just solder these wires directly to these pins. Look, in all honesty, if this device fails again, I'm going to throw it out. I'll get sick of it. So let's not worry about how neat this job is or how future-proof serviceable it is. Now, the other issue is we, of course, have to secure this end of the board because we don't want it sprunging around on those 2 screws. That would generally be bad. So you'll notice there's no feet on the bottom of this. It's flat. And that's sort of good. I don't want anything protruding out the bottom, because what I was thinking I could do is drill and tap a couple of new holes in the bottom, then use, like, you know, computer screw standoff type things, which I have in a lot of different sizes, and just screw those in, and bada bing, bada boom. If this thing had feet, those might stick out a tiny bit, but it wouldn't matter. In this case, I need the bottom to be smooth because this fits onto a shelf in a rack between 2 pieces of equipment, and the thickness of the shelf plus the thickness of this unit means it just slides in there. So I can't have anything protruding off the bottom. Now, of course, I could drill and tap, screw in a couple standoffs, and then just like Dremel them off on the bottom, but that would be nearly impossible to do in a perfectly flush manner without damaging the bottom of the case in this finish, and I don't know what metal this case is made out of, but that could start corroding. Not that it would be in a high humidity environment, but just as a general rule of thumb, if I can avoid it, I don't want to... Well, actually, the metal's still coated there. As a general rule of thumb, I don't want to scratch metal down to... or scratch finished metal down to bare metal. So I prefer not to do that. What I could do is just put a couple of blind standoffs there. And that might be what I'll do. And by blind standoffs, I don't know if that's the correct term, but I mean like standoffs that have threads, thread going all the way through, so that basically this end would be anchored, this end would not, but it would at least be supported from bending down and hitting the bottom of the case and potentially shorting out. The other option is, of course, to 3D print or otherwise fabricate an adapter to go under this board. And if it's, 3D printed or something, you wouldn't have to worry about it shorting out if it's made of plastic. And then the end of the board could rest on a plate that you put under here, and the plate could attach these 2 points, and then the board could attach to the plate. And that would be fine. At least, it wouldn't be like manufacturer fine, but it would be fine enough. So I think, let me try that. Let me see what dimensions we're working with here. So those standoffs are 9.15, 9.15 millimeters tall. I bet that's an exact amount in inches. Kind of weird measurement, but still. All right, I'm back, and I got my 3D print all done. It was ready rather quickly. I've only been gone for about 3 minutes. I have a very fast 3D printer. Ignore the writing. The printer prints that automatically. We could just put it this way if you prefer. Yeah, that's my 3D print. It's not quite finished yet, but you can see I got lucky and had a piece of wood that is just about flush at the top of these standoffs. I mean, it is actually flush. Maybe it's like 0.5 millimeter lower. So it's just about perfect. Needs some finishing touches, though. The good thing about this 3D printing methodology is that the tolerances are quite wide. And a little blowout on the back, but we're not concerned about that because no one will see the back. No one will see the front of this either, except me and anyone who watches this godforsaken YouTube video. I don't know, this drill bit's was indeed too small. That's alright. Believe it or not, despite living in the US, I do have metric drill bits. These just happen to be SAE, and this is a... the previous drill bit was a 13/64th, and this is a 7/32nd. Believe me, I prefer metric. Like, oh, hand me the 7/32nd drill bit, please. Just ever so slightly larger. Yeah, I should have stuck with where I had it before. They're not perfectly centered, but that's more than fine. Now these screws are, of course, slightly larger than the standoffs, but only ever so slightly. But what I've done and gone and done, I don't know, whatever I was trying to say there, is get these other larger washers, and I think you can see where we're going from here. And as I'm sure all of you keen viewers are well aware, wood is an electrical insulator, at least up to, these kind of household voltages and low voltages that we're talking about. Unfortunately, one thing I didn't take into account, I should have actually gone for a piece of wood that's slightly smaller, because although this is like pretty much flush with the bottom of this PCB, of course the component leads are sticking out, and even between these 2 screw holes. So the unfortunate thing about wood is you need to leave a fair amount of margins to avoid splitting the wood. So I can't like go real tight to those screw holes and let the board settle down. So now it's a little proud on this side. So, as long as we're being ghetto, we got a fairly wide margin here, although that's probably for electrical safety. And this is a ground connection anyway. So what I could do is get a couple of small metal washers put them under there, and we should be fine with clearances. Now, of course, we all know the one downside about wood, especially as an electrical insulator, is that it's flammable. So if this board did go thermonuclear, it could burn this piece of wood. It sounds bad, but this is in an all-metal chassis, and the wood most likely isn't going to combust in a violent flame. It's going to smolder and maybe flame a little in this metal enclosure in a rack between two other metal chassis. In other words, the risk is low. This is a very small amount of combustible material. And the reason I have this electrical tape is just to get ahead of myself, because, like I said, there's a decent amount of clearance right there when I put a metal washer below it. But you can see it's kind of close to those pins right there. And those are line voltage, so we will increase the safety rating. Look, none of this is stuff like I recommend as like the ideal way to do it. This is just the way I'm doing it. And I'm comfortable with this. If you're not comfortable with this, then by all means don't do it this way. And then we punch a small hole in the electrical tape, and now we have an insulated washer, which is of course going to be a little bit thicker than this washer. I mean, to be fair, if we're looking at tolerances, but I don't think that tiny difference is going to make much of a difference. This is the side next to the live connections. I was putting that in the wrong spot. And this side has little pads to ground, and that's where these Class Y safety capacitors go. That's what those two pads are. So this is meant to be grounded. So we're going to leave a bare metal washer there, and that should be fine. And this electrical tape is not going to, you got to be careful with electrical tape in that situation, because if it were in a pinch point between one of these, leads coming out the bottom of the board, the lead would just poke through the tape and render it null and void and useless. The point is, the tape's going to be in contact with this flat section. It's really more to insulate the side of the washer and like the parts of the washer closest to these contacts, which is why we are going to put the fold of the tape that way. And it's just to prevent arcing, really. There's going to be no contact between the washer and these pins at all. It has enough clearance here. Just keep that in mind. I'm not advocating using one thin piece of electrical tape as your entire safety margin between a live and the outer shell of a metal chassis that you might touch. That's just to prevent arcing between one of these pins, which it probably wouldn't arc anyway, because there'd be a few millimeters between them, like probably about that much space. It probably wouldn't arc over at these voltages, but just in case, we put a little extra insulation. That's all I'm saying. I'm not saying that electrical tape is the be-all and end-all for every single insulating circumstance. How am I always losing things? Where did I put that other screw? Okay, I am baffled. I'm going to use a different screw. And then the only thing I need are two small, like, wood screws to drive in there. And these are too fat. These are the right length where they won't bottom out, but they're definitely too fat. And they have a fluted head. I'd prefer a pan head in this circumstance, obviously. Give me another second. Yeah, where is my screw box? Like my computer screw box. Oh my god, no. I couldn't find that forever, and now I can't find it again. Where in the shit did I put the screws? Where in the shit did I put the screws? Where in the shit? Where in the shit? Where in the shit did I put the screws? Where in the shit did I put the screws? Where in the shit did I put the screws? Where the fucking shit are all of my screws? No, seriously, where the fuck are they? And we have to worry about clearance a lot less on this end, because this is going to be the low voltage end. Unfortunately, I only have, I had screws that are too long, screws that are too short. If you're the type of person that likes everything done just right, with lots of fancy and perfect 3D prints, made with special graphics and everything looks just so, and is totally awesome all the time, you're watching the wrong channel, I think. Like, for example, sawdust in my electronics. Not that I want it in there. I blew it out, but you know what I mean. Like, some people are going to get, you know, and I can't blame you. You know what? Let's be extra about this. But as much as, and then I need another screw for this side, but I'm not too worried about it because this power supply isn't going anywhere. You know what I mean? Now, before I connect these leads to the board, let me just make sure that the polarity is correct, because I was going by the printings on the PCB, but we all know sometimes the printings on the PCB can be wrong. I'm going to be confident enough to assume the thing's isolated properly. Yes, it is. I'm not getting a shock through my chest. And we got 5.11 volts positive, which means the polarity is correct. Now, these are square pins. I actually recently purchased a wire wrapping tool just to have some fun with it, but I think the wires it would wrap would be too thin, and I would need solid core wire in this diameter, which I don't think I have, and it generally would all go to shit if I tried doing that, so I'm not going to do that. Look, you and I both know that there is some engineer watching this video who is shitting their pants in rage at this. But, yeah, that's what we're going to do. So basically what I've done is I wrapped that component lead around 2 of the pins, and then what I did is put the wire in between the 2 component leads, or the 1 component lead that's bent around, and the 2 pins of the connector, and blobbed a bunch of solder in there. And I think that's actually a good way of doing this, better than just putting in parallel and trying to get some solder between them, because this is going to create a really solid joint. It may not look that great, but from an electrical and mechanical standpoint, it'll be fine. Or so I tell myself. I'm just sort of experimenting here. Freeballing this. I don't know, man. Like, that's not going anywhere, and it's got a good electrical connection. And now, on my messy bench, let us test this out. Alright, plug in the monitor, and I'm going to turn it on right about now. And let's see what happens, if anything. Okay, light in the chassis is glowing purple right now in the front. That is a very good sign. I believe it takes a moment to start up. The suspense is killing me. Is the monitor cable plugged in? Yeah. Oh. Oh. It made the noise that it usually makes when it starts up, but no, why is no video coming out of this thing? Is that just the monitor being pissy? Let me just unplug the monitor and plug it back in. Because the front light is glowing blue on the unit now, which is... Oh, yeah. Oh, it was just the monitor that was pissy. Okay. That's fine, or the monitor didn't sync with the device. Yeah, that's what we want to see. Hooray. And then I'm just curious, what is the voltage drop, or what is the voltage coming off the PSU when it's under load? 5.08 volts. Oh, you guys can't really see that, but yeah, 5.0869 volts. I could, in theory, probably use that pot to dial that in to exactly 5 volts, but should I? No, you know what? I'm just going to leave it, because slightly higher voltage is going to get some voltage drop on the tracks on the board, wherever else. I mean, that's like after, actually, you know what? I'm just going to leave it, because that might be the voltage. I mean, this should be well regulated, but that might be the voltage when it's under very low load. Is this heatsink? Yeah, the heatsink's warm, but not hot. But like maybe if I have multiple sessions open, I think this supports up to 2 sessions, and it's doing a lot of activity, then it might draw more current and drop that voltage a tiny bit more. But yeah, okay, cool. Cool. And let me just, for the sake of argument, make sure that was the monitor. So I'm going to shut it off. I will go back to the monitor and flip the switch. And you can see the standby light is yellow now. It was green before, and it was saying like no signal even when it was hooked up to this. So this is more the correct behavior for the monitor. And once the system boots and we hear that beep, we should have video by then. Yay, okay. Now it's showing the whole boot process. And for those of you that were curious, that is the boot process. The only oddity, I guess, is that the fan isn't spinning, but I don't know if it like only turns on when needed. It's not turning very freely, but is that just because now this fan might be a little shot, because its bearings might be shot, because like, is it applying voltage to the fan connector? Yeah, it's trying to put 5 volts out to the fan. Well, damn. So the fan is shot. I mean, sometimes a spot of oil in there, like very fine oil, will get a fan going again. So I wonder if the failure mode for the power, because it's definitely the power supply that failed. I don't think it's that this overheated and then that somehow caused the power supply to overheat and the capacitors to bulge and then this to fail. I mean, that is a possible sequence of failure, like the whole chassis heats up from lack of airflow across this. But then again, this fan isn't exhausting really much air out of the chassis. It's just getting air off of this heatsink and into the rest of the chassis. So I don't really, it would be local heating that would be the problem here, and not heating of the entire chassis. So I'm still more inclined to think that something in the power supply failed first. It could also be the fan failed, drew way too much current. That caused the power supply to overheat. So would it shut down in an overcurrent circumstance, or would it just overheat and die? So anyway, yeah, possible the fan failed, pulled way too much current, caused the power supply to overheat. That caused components and or capacitors in it to fail, which maybe caused a cascade failure within the power supply. And then, yeah, the fact is we'll never know, but this fan is definitely shot. So I'm not going to put that in the video. I will look for a replacement for this. I might have one on hand. I should have tested that on a bench power supply independently, because I just assumed it wasn't spinning because maybe it had some kind of thermal cutoff, but I think it is supposed to spin all the time, because there was voltage here at this connector. That's annoying. So anyway, thanks for watching. That's been the haphazard repair of this thing. Raritan Dominion DLX108. It says LX. Oh, DLX108 is D stands for Dominion. On the bottom it says DLX. Jesus Christ. On the bottom it says DLX108. On the front it says LX108, but Dominion. But anyway, none of that matters. I'm curious, what does everyone think about using wood inside a piece of electronics? Like, yay or nay? I obviously say yay. Look, I wouldn't have done it this way if this wasn't a cheap thing in the first place, and it wasn't like probably the easiest way to do this, and it, like I said, very secure. I think it's fine, but I'm sure some people will hate this. Let me know what you think in the comments. I know I didn't do a great job here. I know that. I wasn't trying for perfection. I'm trying to get this thing to work. I don't really care how it looks. I don't really care if someone gets mad at me about it, as long as it works, and it'll work. Like, it will work. You can't tell me this won't work. That's the thing. Like, you could say, it's horrible. Why would you do that voice, though? I don't know. But the fact of the matter is, I bet this thing works for another 5, 6, 7, 8, 9, 10 years. Should have just upgraded it from the start, but then you wouldn't be able to see me do... I've never seen anyone repair a high-tech device like this with wood. At the very least, give me credit for doing something that you don't usually see on YouTube, even though it's dumb. I don't know if that helps. Whatever. Anyway, thanks for watching. Evan Scott. I'll get a new fan. I'll put this back together. It'll be fine. So long. I'm just going to salute now for every video. That's it. Oh, tail sleep. Yo, like and subscribe and whatever the fuck. I don't know. I figured I'd do an epilogue, actually, because I ordered a couple of new fans from Mauser. And there they are. I got 2 because this is a fairly common fan size. Figured it can't hurt to have one in stock. Put it in my parts bins. The dumb thing is, if you saw my previous video, I had two fans of exactly the right size that came out of a little disc enclosure. And to be fair, I had actually forgotten about these at the time I ordered the Mauser fans. I didn't even try to see if they would fit. Then I realized afterwards they would. But the whole reason I took them out of the drive bay unit in the first place is because I never heard this brand. I didn't trust the quality of these fans. I didn't trust them to run for a long time without making weird noises or just seizing up entirely. So I'm still not going to use these, even though they would fit just about perfectly. They're the same dimensions. And I do believe they're 40 millimeters by 10 millimeters. And actually, just out of curiosity, what brand is in here? Sunon. And these brand new fans are Nidec. I did not bother checking CFM, air pressure, anything like that. It has a completely different blade design, or at least a little bit of a different blade design. But I don't think it matters. This just lightly blows air across this chip. I think whatever this does is going to be good enough. I want to do this whole epilogue just to show you the fan replacement process. It's not terribly complicated, but the fan is attached to this metal bracket, and unfortunately the fan is screwed in from behind. Sorry, it's a little out of focus. I'll show you when I take it out, but there's a screw head there and one diagonally opposite it down at the bottom. The bracket, I thought, was screwed in from below. Like, you can see it's got a couple of nuts there. I thought those were attached to screws from the bottom, but you can see from the scratch marks, I thought these were just like plastic or nylon covers. Pop them off, get to the screw heads. But no, it appears to be that's metal. I think it's either pressed or welded in there. So the only way to get this bracket out and therefore replace the fan is to get a nut driver of the appropriate size. So, one moment, please. Of course, it's SAE. These are probably metric nuts, if I had to guess. So, yeah, I'll be back. Yeah, this is a weird shaped tool. Holy shit. I'm pretty sure I have some other metric drivers in the garage. I'm just being lazy and trying to find something that'll work in the basement. Yep. Alright, so once at great length, this is not magnetic. When in doubt, use electrical tape. I have a feeling getting these back on here without a magnetic tip is going to be a struggle, but hey, whatever. And there we have the two nuts. You disconnect power to the fan, and then it's got this little zip tie connecting it to the front power LED indicator wire or indicator cable. Doesn't really matter. Now the only issue is, of course, the replacement fans I got don't have connectors, but they do have nice long leads. So if I had the appropriate style connector, I could just crimp it on the end of here and run it over there, no problem. I could do the ghetto thing I did earlier, which is to solder to the fan connector, but instead since this fan's dead anyway, I'm just going to cut this, splice it, and then move on from there. And yeah, so here you can see the bracket and the fan just being held on by two screws diagonally. Yeah, I mean, the fan isn't really dusty, but it is a little grimy, just I think from years of operation. It just has like that thin film of like hard-baked dust, and it's basically seized up. It won't spin freely at all. And let's just compare it to the new fan. You see the new fan's got fewer blades, but it does spin freely. Measure once, cut once is what I say. I'm just going to do the splice like this. Oh, heat shrink tubing. I think I got the lengths a little bit off. Yeah, the red wire is a little bit longer than the black wire, but it's going to be, I'm going to bend it out of the way similarly to the original installation, so no big deal. So the airflow indicator arrow is there. It's kind of hard to see. There we go. You can see it in the reflection. And so we want the fan to be facing this way with the bracket behind it. And I think, yeah, since I'll have the wires coming out this way, you'll see that's going to route them back towards the power LED cable where I'm going to zip tie it again and back from whence it came. And now this just gets mounted back in the old chassis. There we go. Nope. Shit. My fingers can't... Fuck. How did I do the first one so well? My fingers won't fit through this gap, so just use the screwdriver to sort of guide it in there. Want those in, I mean, not like overly tight, but don't want those nuts coming loose and rattling around in here, especially shorting out something on the high voltage side of the power supply. That would be messy. I guess, to be thorough, I could have tested these fans with a bench power supply before trying to use them, but let's just do it the old-fashioned way and grab a power cord, switch it on, and yep, that fan just started spinning. It's got a nice breeze to it. Can I visually represent this to you? Here's a lighter piece of plastic. Yeah, so you can see the airflow there. And so just as, I guess, from the factory, it was like pulled a little harshly, I thought, previously, so I'm going to like leave a little bit of slack. Not enough so these cables can, or so these wires can get into the fan. And of course, these side cutters are the best things for getting zip ties cut nice and flush, because after all, that's kind of what they're meant for. Oh, and I guess some of you might be curious about how loud this fan is. As we know, it's loud in the basement, and this is going into a data center. So I can't really give you a measurement right now because the background noise is going to be louder than this fan. But I'm just going to spin it up again, put it to my ear. And yeah, it's not the quietest tiny fan I've ever heard, but it's relatively low RPM. It's not buzzy at all. Once the case is closed up, I don't even know if you'd hear it. Maybe in a completely silent room, you could vaguely hear it if it was like right next to you. I don't know, but it's very quiet. And the next step is just to close it up. Hope that I didn't lose the case screws in the process of all this faffing around. Yeah, they're right here. At least I hope that's all of them. And then the only thing is when closing the case, it's got a lip here on the front that goes under here. And then it has a tiny tab there, which hooks into a slot there. So presumably we just put the case on like that, slide it forward, and yeah, that's really all there is to it. I guess what I should do is just make sure this thing works one more time now that I've closed it up. Because, you know, that happens sometimes. You close something up and you realize you forgot to, I don't know, make a connection or, you know, whatever happens. And then it suddenly doesn't work when you go to power it up and it's something stupid. Obviously, I would hate to bring this back to the data center where it lives just to find out that it does not, in fact, live. I guess I could orient it like this. You can see the power LED simultaneously with the monitor. And like I said, the power LED looks purple to my eyes. It's kind of overexposed in the camera. There, if I turn it that way, you can kind of see that it's more purple. It's kind of white there because it's too bright for the camera's exposure settings. But yeah, purple. So I think it's red for error, purple for sort of booting or doing some other activity maybe, and it's usually blue once it's powered up and working fine. So it should beep loudly and go to a solid blue. Yeah, yep, there it goes. Beeps loudly and it's blue. And we have the login screen. So I don't actually have any of the dongles. Actually, I think I do have compatible dongles here, but I'm fairly confident if it doesn't work by now, it's not going to work. So anyway, that's it for the video. Yeah, thanks for watching the epilogue. See you later. Not see you later. What's a good ending